Okay, guys, so we were here, right? And we just found the velocity of the color at A, right? And what do you guys think about this so far? Is this all clear to you guys, or how we are setting this up? Right, so we know SA squared plus 2 squared has to be equal to S squared. And then, by the way, okay, so we differentiated this guy. We ended up with 2 SA prime. Derivative of 4 is 0. It's going to be equal to S, or 2 times SS prime. 2 will cancel out, so we're going to end up with SAS prime is equal to SS prime, right? And finally, we got SA prime is equal to S times S prime, right? So we know S is equal to square root of 1.5 squared plus 2 squared divided by SA. And then we said S prime is equal to 6. So is that true? Is S prime actually equal to 6? What is S prime equal to? Is it equal to 6?
Yes.
Yes, it's equal to the velocity at B.
Right, yeah. Well, okay, so what is actually S prime? S prime is the rate of change of this cable. مش هيك؟ So, you're measuring the length of the cable, it's 2 meters, right? After an instant dt, it is like, 1.9 meter. And then after an instant dt is maybe 1.8 meter. So SA prime is simply the rate of change of the length, right? With respect to time. So I think here, S prime should actually be negative and not positive. Why? Because if the velocity of B is positive, it means that this length here is basically reducing, right? And therefore it must be negative. So SA prime is actually opposite to, is actually negative. All right. So just, this is basically what is actually happening, right? So S prime is the rate of change of this cable, right? And then here, we cannot really write the actual length of the cable because length of the cable is actually decreasing, right? As a result of having this spool or motor over here. All right, so we can't say that the length of the cable is constant because we are basically drawing that cable. All right, but what we do know is, whatever rate of change of this cable is going to be equal to minus the rate of change of this cable. Okay, now let us find the acceleration. How can I find the acceleration? We're gonna?
We derive the second equation.
Exactly.
Differentiate
this guy. So if you differentiate this guy, what are you gonna end up with? So it's gonna be SA prime square plus SA double dot is gonna be equal to S prime square plus S double dot, right? And we're interested in finding SA double dot. So what is SA double dot? SA double dot is going to be equal to S prime squared plus SS double dot minus SA prime squared. The whole thing is divided by
acceleration تطلع positive, Dr. Mahar.
acceleration. Well, we have to kind of calculate that and then see what happens. So we know what is S prime squared. S prime is going to be equal to how much? S prime basically is the rate of change.
6
minus 6, right? Minus 6.
بس ما squared.
Yeah. Okay. Well, we still have to write. So minus 6 squared plus S times S double dot. What is the length S? Well, we have it, right? Square root of 1.5.
2.5 تطلع هي.
Plus 2 squared, exactly, multiplied by S double dot. What is S double dot?
Minus 1.5. مش minus 2, sorry.
Minus 2. Why minus?
Yeah, 2.
Why minus 2?
Because it's opposite.
Exactly.
واحدة رايحة على right, واحدة رايحة على left.
Exactly, right? So S double. So here, basically, you're drawing the cable with that acceleration. So this length here basically is reducing by the opposite of that, right? Okay, and then I have minus S prime A squared, which is equal to how much? I would have to calculate this, okay? I have to put a number on here. So minus S prime A squared. So we have already calculated that. Okay, so we know S prime A is equal to how much? 10. Okay, thank you.
Yes.
The whole thing is divided by SA, right? What is SA? 1.5. Okay, let's kind of clean this up and then resolve this. So SA double dot is going to be equal to 36. You mentioned this guy is equal to how much? 2.5, right? Square root
Yes.
of, okay, 2.5 times minus 2 minus 100, right?
تطلع minus 46. بس دكتور I have question.
Yeah.
You said إنه ما فينا نعتبر that the cable has a constant length. بس can't we consider إنه constant length والموتور عم بيزيح على الرايت? Isn't it the same? بما إنه it has a
You
VB.
can, exactly, yes, you can consider it that it's the same length, but the motor is basically pulling it to the right.
Okay.
This is one of the best way of doing that, or you can consider it, it's a very easy problem. So let me show you how you can also, so you have this, right? This is point B, right? And then this is A, okay? And then this is a pulley. So I can actually put my datum here, and then I can say this guy is my SB. Okay, so I can consider this point that is just at the top of the cable.
Yes.
And then I can do this, right? This guy is S. Okay? So I can say that the actual length of the cable is equal to what? SB plus S, right? At that instant. Okay?
Yes.
So I can basically consider a point that is right at the top of the cable, right? So if the motor is drawing it, then it's fine. The motor can draw it, right? If I differentiate that guy, I'm gonna basically end up with 0 is equal to VB plus V, right? So you can see now basically, or basically is S prime. So you see that S prime will always be equal to minus VB, which is what we just did, right? So basically what I'm considering is I'm considering a point on the cable, right? And I have the velocity of that point. I know VB and I know AB, okay? So I consider this portion of the cable, and I'm saying that this portion of the cable, right, is constant and is given to me by SB plus S. So if I differentiate that, it's going to be S prime is equal to minus VB. So it doesn't need a huge imagination. All you do basically when you have a pulley, if the angle across the pulley is not changing, and if you are basically pulling this guy with the velocity, this guy is going to be coming to you with the opposite velocity, okay? Assuming that your reference frame is always, you know, outward. All right, so make sure you are solving all these problems on pulley systems, compounded pulley systems, and you will get the heck of it very easily. All right, so make sure you are understanding the absolute frame. So if my, you know, datum is here, I set a point here. Basically, if SB prime is positive, it means that point B is actually going away from my datum, right? And here, if S prime is positive, it means that A is going away, right? So if I consider this portion of the cable, I can write L is equal to SB plus S. So if I differentiate these guys, I'm going to get 0 is equal to VB plus V, right? So if VB is positive, basically, right, then V is going to be equal to minus VB, right? So basically that velocity, so if this guy is going, you know, to the right, meaning SB prime is increasing, then my V is going to be decreasing. Why? Because this guy is positive. So if I move it on this side, it's going to be negative. Okay, so S prime will be minus VB. So this is, you know, very simple. So just make sure you are solving all these problems for you to understand how all these basically works. Okay, so relative motion. So I think we have something, you know, we're done basically for today. It's already 11:50. So it's very important that you solve all the homework assignments, you know, spend all your time to really fully understand it, work on it on your own, and try to, you know, solve at least 2 or 3 problems on a daily basis. And what I've also suggested is that you guys should go on OpenCourseWare. So there's a lot of universities that actually publish all their coursework, like, you know, their exams, assignments, etc., are posted on Blackboard. I'm sorry, like online basically, and they make it public. Okay, so make sure you like Google sample Dynamix exam 1, and then try to solve as many problems as you can. Usually they are exams with solutions basically, so they are kind of a little bit challenging, but by you spending the time sitting on them and then solving them, I think you will get it, and that will prepare you very well for the future. Okay, guys, so I'm done here. If you have any questions, I'm happy to take them. Other than that, I think we're going to be good for today.
Doctor, I have a question.
Yeah, sure.
When